Hello, everyone. Welcome to Pre-Lecture 5 for Chem 152. In this lecture, we're going to be talking about liquid-liquid solutions and liquid-solid solutions and the concepts behind them. It's going to be found in Chapter 11 in your textbook. So last time in class, we started by, or rather we ended by discussing solutions of gases and liquids, how that can be quantified using Henry's laws, and how as the temperature of our solution increases, most oftentimes the solubility of our gas decreases in that solution. Okay. So today we're going to talk about liquid-liquid solutions. And so these are interesting in that obviously both our solute and our solvent are starting in the same phase. And so if these two liquids are mixed together to yield a new solution, and if they are miscible, we would say that they actually have an infinite mutual solubility. Okay, and so what that relates back to on the molecular level is that these miscible liquids will have similar intermolecular forces. And as a rule, typically polar solvents will dissolve polar solutes, and nonpolar solvents will not mix. Oh, there's a typo there. Nonpolar will mix with nonpolar. So like goes with like. Okay. This relates back to there being no appreciable energetic difference between our solvent-solvent and solvent-solute interactions for miscible liquids. So a reminder that this all goes back to, of course, intermolecular forces. And in order to have two things mix, we have to overcome the solvent-solvent interactions and the solute-solute interactions. And it ultimately has to be more energetically favorable, or at least equal, to have the solvent-solute interactions in order for things to be miscible. Okay. And so, of course, like this picture we have on the right here, where it looks like we have some sort of oil on top of water. When we have intermolecular forces between two liquids that are not alike, so say on our top liquid up here and our oil, we only have London dispersion forces. And down below, we only have hydrogen bonding with our water. In that case, we're not going to have any sort of successful intermolecular interaction between our hydrogen bonds of water and our London dispersion forces of our oil. And that means that these two are not able to overcome their solvent-solvent interactions or solute-solute interactions, and they will ultimately be immiscible, or they will not mix. Okay. If we think about solids dissolving in liquids, I'm sure you know, and we've discussed in class that many polar and even ionic solids, such as salts, are capable of dissolving in as solutes in water, which is our most common solvent. Generally speaking, the concentration of a solid at saturation will go up with a solution's temperature. And so if you look at this chart here on the right, you can see that something like table sugar starts very high and it only gets much higher as we heat our water, our solution. Something like potassium nitrate changes quite drastically over temperature here, going from 0 degrees Celsius up to about 80 degrees Celsius. And then we get some minor changes for things like sodium bromide that you can see that it's not very temperature dependent, but we still have a slight rise. There are, of course, exceptions. And so an example in this table is cerium sulfate here. And so this isn't a hard and fast rule, but generally speaking, the concentration of solid that is able to be dissolved in a liquid will go up with temperature. And as I stated with the liquid-liquid interactions, the same is true here, of course, that our solute-solvent interactions must be energetically more favorable than in order to overcome our solute-solute interactions and our solvent-solvent interactions. And of course, our intermolecular forces must be compatible as well. Okay. These are a couple gifts that I like of sugar dissolving because it's super soluble, especially in the form of cotton candy where it's quite diffuse. And so that was someone dipping some cotton candy in water and watching it dissolve in their hands. My other fave, which is a little bit more sad, is this raccoon who was given some cotton candy and sadly sees it disappear before their eyes. And so can be sad for the raccoon tonight or whenever you're watching this, but if you have cotton candy and you would like to enjoy it, I would recommend keeping it away from water. That's all for our pre-lecture today. If you have any questions, of course, feel free to let me know either via email or, of course, when we get together in class. All right, everyone have a good day.